question number 10. We have to calculate the number of atoms in 20 gram of neon 20 and the upon number of atoms in 40 grams of krypton 80. So if I have to calculate the number of atom, that is given by number of moles into Avogadro's constant, but I don't have the number of moles, so I can calculate the number of moles as mass of substance over mass of 1 mole of the substance. Mass of 1 mole. So if I have to calculate for neon, mass of substance is given as 20 and 1 mole is 20. So 20 by 20 gives me 1. Similarly, if I have to calculate the number of moles for krypton, it's 40 over 80. So 40 over 80 gives me half. So keeping it here, number of atoms in neon over number of atoms in krypton will give me N and A, that is this is 1 and this is half into Avogadro's constant, which cancels out, so this gives me 2. So the correct option is C. Moving to question number 11. A wave is traveling on a string. The two graphs are given, one is displacement versus distance and the other one is displacement versus time. We have to calculate the speed of the wave. So we know that the speed of the wave is given by the wave equation, v is equals to f lambda. F can be written as 1 by t. So now I should know lambda and I should know time, and I will substitute it in the formula. So in order to calculate lambda, which is the wavelength, I can use the first graph. So from crest to crest I can see it's 4 centimeters. So lambda is basically my 4 centimeters. I'm not converting it to meters as my options are also in centimeters per second. In order to calculate time, I can use the second graph, which is displacement versus time graph. So time period is basically for one wave, so one wave is going till 2 seconds, so my time becomes 2 seconds. Substituting it in the formula, v is equals to lambda by t. Lambda is 4 and this is 2. Lambda is 4 and time is 2. It gives me 2 centimeters per second. So the correct option is A. Question number 12. Unpolarized light of intensity I naught is incident on a polarizer with a vertical axis of polarization. The transmitted intensity of this polarization is I1. So let's draw the scenario. So we have unpolarized light which has vibrations in all the directions. It has an intensity of I naught. Now it passes through a polarizer, and polarizer has a vertical axis of rotation. So obviously when this unpolarized light passes through this polarizer, half of the oscillations will get absorbed, so the light which comes out will be half of the energy, that is I naught by 2. Then they say there is a second polarizer again, which again has a vertical axis of polarization. So again same kind of polarizer with vertical axis of rotation. So there will be no change in the intensity as the axis is same. So the intensity coming out of the second one is also I naught by 2. So this is I1, this is I2 as per them. So both are I naught by 2 half. So the correct option is B. Moving to next question, question number 13. A wave is traveling from medium 1 to medium 2. So if I just draw a normal over here, I can clearly see that the light which is incident in medium 1 is bending towards the normal. It is bending towards the normal. So whenever a ray bends towards the normal, that means it is traveling from a rarer medium to a denser medium, right? That means the refractive index of this one is less than the refractive index of the second one. So clearly the option cannot be A or B, either it is C or D. Now we have to compare their wavelengths. We know that the speed of light is proportional to the refractive index. That means if N1 is less than N2, V1 will be more than V2. Now using the wave equation, V is equals to F lambda. So more the velocity, more is the wavelength. That means lambda 1 is also greater than lambda 2. So I've got two equations, that the refractive index of first is less than the refractive index of second, and wavelength of first is more than the wavelength of second. So if I just use C, it's C or D, its option is C. Question number 14. First harmonic of a standing sound wave established in a tube. which is one end open and one end closed. So if I just take a tube, and they're saying the first harmonic. The first harmonic means this, where we have just one node and one antinode. So with this is antinode on the open end and this is node on the closed end. And let's say the length of this pipe is L. So I can clearly say that L is equals to lambda by 4, as the distance between a node and antinode is lambda by 4. Now they say that the length is now increased. Length is now increased a little bit, 0.10 meters. And the next harmonic means I will have two nodes and one antinode. So I can draw it like this. So now I have one antinode on the open end and I have two nodes. And if this is the total length, now becomes L plus 0.10 meters, and that will be equal to this distance between two nodes and then one node and antinode, which becomes lambda by 2 plus lambda by 4, which gives me 3 lambda by 4. So I can write L plus 0.10 meters is actually equal to 3 lambda by 4. Now L I had already calculated from here, so I can substitute it as lambda by 4 plus 0.10 meters will give me 3 lambda by 4. Solving out this equation, I get 0.10 meters gives me 3 lambda by 4 minus lambda by 4, which is 2 lambda by 4. So solving it for lambda, I will get lambda as 0.20 meters, which is C. Question number 15. So we have 2 point charges, plus 4q and minus q, and they are placed a certain distance apart. Where is the electric field strength equal to 0? Now we see that this is a positive charge, so the field will be away from it. The field will be away from it everywhere, and from minus q the field will be closer. Secondly, because they are not of equal magnitude, the electric field strength cannot be 0 in the midway. So it is somewhere closer to minus q, because that is a weaker charge. Plus 4q is 4 times stronger than minus q. So the field strength will be 0 somewhere close to minus q, and that too further away from minus q. So it cannot be A, it cannot be B. From C and D, obviously it will be away, because we have a much heavier charge, a much stronger charge. So it will be away from minus q, which is D. So D is the correct option. Question number 16. A cylinder of copper with diameter D and length L has a resistance R. So I can say resistance is equals to rho L upon area, that is length upon area. Because they are talking in terms of diameter, so I can write it as pi d square by 4, which goes here. So this is the resistance of this copper cylinder. Now they are asking us to calculate the resistance of copper cylinder with double the diameter and double the length. So I use this formula rho. Instead of length I can write it as 2L, and instead of diameter I can write it as 2D squared. Simplifying this equation, I get 2 rho L by 4 pi d square. So if I just take out the actual formula is 4 rho L by pi d square. So this 2 by 4 is extra, which becomes 1 by 2 R. So that means the resistance will become half. So the correct option is B. Question number 17. So we have the path of three particles with identical magnitude of charge but different mass is shown as they enter a region of uniform magnetic field. So the particles have the same initial velocity. The magnetic field is directed into the plane of paper. Now we know that the force is calculated by the formula BQV. Now because they take a circular path, this is centripetal force, which is given as mv square by r, can be written as BQV. So if I have to calculate the value of basically r, so R will be equal to mv by bq. That means the one which is taking a larger radius will have the largest mass, and among all this particle x is taking the largest radius of the circular path. So I'll say that this is the larger, it has a larger mass as compared to the other two. So obviously the option C and D cannot be the options. So either it is A or B. Now if I talk about the sign of charge, this particle is going in this direction, so this is the velocity. So centripetal force is always towards the center, or we can say it's perpendicular to the velocity. So at any point you take, the force will be towards the center of the circle if I consider to be an arc a part of the circular motion this particle is taking. So if I apply my Fleming's left hand rule, if I apply left hand rule, I can find my middle finger, which is basically will come out to be in this direction. So current is basically flowing in upward direction. So this particle X means it's negative. So larger in mass, sign is negative. So correct option is B. Question number 18. The mass of planet X is 300 times mass of planet, let me write it like this. Mass of planet X is 300 times larger than mass of Earth, and the radius of the planet X is 10 times the radius of Earth. So I know that gravitational field strength is given by the formula Gm upon r square. Now they are saying that this is my uh, the mass for the one is basically 300 times the mass of Earth and 10 times the radius of Earth squared. So it becomes G into 300 into mass of Earth over 100 R into radius of Earth squared. So basically this Gm by E square is actually my radius, sorry, my gravitational field strength for the planet. So if I just solve it out, it becomes 3G, which is C. Question number 19 says a sample of artificial element has this much of atoms and it has a half-life of 15 seconds. So I can say the half-life is actually 15 seconds. They're asking how many atoms will be remaining after 1 minute. So 1 minute basically is 60 seconds, or I can say it's 4 times of 15 seconds. That means 4 half-lives. So initially I had atoms this much. So after one half-life it will become 10 to the power 22, then it will become 1 into 10 to the power 22, then it will become 0.5 into 10 to the power 22, then it becomes 0.25 into 10 to the power 22. So one half life, two half life, three half life, and four half lives. So my answer is 0.25 into 10 to the power 22. But I don't have 0.25, so I can rewrite it as 2.5 into 10 to the power 21 atoms, which is option A. Question number 20. So we have a pi meson can decay as shown in the equation. So this is a meson and this is clearly an anti-lepton. This is anti-lepton. So if I apply my conservation of lepton number, this will be 0. Meson doesn't have any lepton number, and this has to be -1, and if this is -1, this has to be +1 in order to make it 0 +1. So obviously it cannot be an anti-neutrino, it is either A or B. Now because it's positive converting to positive, so we'll have exchange particle of positive W, so it is option A is the correct option.